How to fix Crimson Desert muddy graphics. Adjust DLSS and Frame Gen. Welcome back to Teknobalta. During our rigorous technical testing of Crimson Desert, our team identified severe muddy graphics and visual blur when utilizing upscaling technologies. Our deep dive analysis revealed that default DLSS implementations and frame generation pipelines often desync with the game's internal render resolution, causing a terrible smearing effect. We have systematically isolated the root causes and compiled the ultimate diagnostic guide to restore crisp, pristine. Our primary testing revealed that adjusting the core DLSS preset directly impacts the internal rendering resolution scale of the game. We strongly recommend setting the DLSS mode specifically to quality or ultra quality, as the balanced and performance presets aggressively downsample texture maps. This simple adjustment immediately eliminates the baseline blur effect over distant terrain geometry. Frame generation introduces interpolated frames that can cause extreme ghosting and visual artifacts when the base frame rate is too low. Our diagnostics confirmed that disabling frame generation completely stabilizes the. We advise toggling this setting off in the display menu to immediately restore temporal clarity during fast camera movements. During our deep dive into the Nvidia Control Panel, we discovered that overriding the game's default texture filtering significantly sharpens environmental assets. Navigate to your 3D settings, locate the game executable, and force the texture filtering quality parameter to high quality. This overrides the engine's aggressive texture streaming compression and brings back the micro details on character armor and mud surfaces. Teknobalta's analysis uncovered an outdated DLSS dynamic link library packaged within the game's launch directory, contributing to severe temporal smearing. By manually downloading the latest DLSS version from the official Nvidia repository and replacing the core file, we achieved a massive reduction in motion artifacts. Ensure you back up the original executable before executing this file replacement to prevent potential integrity errors during patches. We identified a severe rendering conflict between the proprietary anti-aliasing solution and the deep learning supersampling pipeline. To resolve this, you must explicitly disable all forms of standard anti-aliasing within the graphics menu before enabling DLSS. Forcing these post-processing effects simultaneously creates a double-filtered muddy overlay that destroys all high-frequency pixel data. Our engineers found that the game's implementation of cinematic post-processing heavily degrades overall. You must enter the visual settings and completely disable chromatic aberration, film grain, and vignette effects. Stripping away these artificial camera lens distortions reveals the true, uncompressed fidelity of the rendering engine. The default motion blur implementation uses a low-sample algorithm that smears the entire viewport during combat encounters. We tested various configurations and determined that reducing the motion blur slider to absolute 0 is mandatory for visual clarity. This completely stops the engine from blending adjacent pixels during high-speed weapon swings and evasive maneuvers. Sometimes the engine's dynamic resolution scaling forces the render scale below native parameters without notifying the user. Our testing showed that navigating to the display options and manually locking the render scale at 100% prevents this automated degradation. This ensures your graphics processor draws every single pixel at your monitor's native resolution, regardless of screen complexity. The depth of field effect utilized for distant background rendering aggressively blurs anything outside of your immediate focal point. By dialing the depth of field quality down to its lowest setting, we successfully restored sharp horizons and clear vistas. This tweak is essential for players who want to appreciate the intricate landscape details, rather than a muddy watercolor background. Volumetric fog and cloud rendering in this title operate on a lower resolution grid than the primary geometry, bleeding muddy pixels into the foreground. We found that lowering the volumetric effects quality significantly reduces the spread of these low-resolution alpha textures across the screen. This drastically cleans up the air around your character and removes the hazy filter present in dense environments. For advanced users, our team explored the Nvidia Profile Inspector and discovered a crucial tweak regarding the level of detail bias. Changing the texture filtering level of detail bias to a negative value forces the engine to load higher quality mipmaps at closer ranges. This completely eradicates the muddy ground textures that normally plague the immediate playable area. If your hardware possesses thermal headroom, utilizing Nvidia Dynamic Super Resolution provides the ultimate brute force solution to muddy graphics. We tested rendering the game at a much higher resolution on a standard monitor, which acts as a flawless supersampling method. This provides unparalleled image sharpness and completely bypasses the game's flawed native upscaling techniques. Applying a driver-level sharpening filter is another highly effective workaround our team verified during testing. Open your graphics overlay, add a game filter, and apply the sharpen module at roughly 20 to 30% intensity. This specific value intelligently sharpens edges and restores lost clarity without introducing unwanted visual noise or grain. Modifying the engine configuration files directly offers profound improvements for users willing to dig into the system directories. By adding specific console variables to disable temporal upsampling smoothing in the configuration text file, we achieved a remarkably raw and crisp output. We highly recommend this advanced step for enthusiast players experiencing persistent blur on native resolutions. Screen tearing and improper frame pacing often disguise themselves as visual stutter or motion blur. Our testing confirmed that enforcing vertical synchronization at the driver level, rather than utilizing the in-game toggle, provides a significantly cleaner frame delivery. This creates a perfectly paced image stream that eliminates the jittery, smeared appearance during camera panning. Finally, corrupted shader caches can cause the game to load low-resolution placeholder textures permanently. Teknobalta recommends navigating to your local app data folder and manually deleting the DirectX shader cache to force a clean recompilation. Upon your next launch, the engine will rebuild these assets properly, completely resolving any lingering muddy texture streaming anomalies. Don't forget to follow Teknobalta for more.